Okay, I think the sound's going to work this time. Last 2 days, the sound hasn't worked. Yes. Okay, guys. Okay, we have a quiz tomorrow just on the formulas. And we're actually going to practice for the quiz. I'm basically giving you the quiz. Yeah, but you're not going to hand it in. But what I want you to do is not to look at your notes, because nobody's going to judge you on this right now. All right, and we'll go over it afterwards. But I want you to fill in what you think all these antiderivatives are. And actually do it. Don't just wait, because this way you'll be able to catch what you don't have, right? You know, you want to be able to write down what you think it is. I'll come around, check the homework, and then we'll go over it. But these are the quiz questions for tomorrow. Just not in the same order. Please don't memorize in order. Kids do that. Okay, let's see how many we can get right. What about the first one? What's the antiderivative of k with respect to x? Man, kx plus c. Some of you put 0, didn't you? Hmm? Sometimes people go the wrong way. Oh, yeah, you're just not saying it. Yep, the derivative of k is 0, but the antiderivative of a constant is kx. Let's see. Ooh, number 2, the power rule. Who's got a hand up? I'm taking it. Yep. X to the n plus 1 over n plus 1 plus c. Beautiful. And if you don't want to put it over the n plus 1, you put out front. 1 over n plus 1 out front. Either way. Anyone 2 for 2 yet? All right. 10. The antiderivative of sine x. And then negative cosine x plus c. Correct. Now, if you wrote cosine x, just remember the derivative of sine is cosine. Antiderivative is negative cosine. And remember, I taught you that sc, negative s, negative c? Did you get that, or was that kind of a blur? Yeah. So if you remember the pattern, sine, cosine, negative cosine, that repeats forever and ever. So whenever you want to take the derivative, you go down one level. So if you're taking the derivative, you go down a level. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cos. And what would the derivative of negative cosine be? Sine. Okay, because it keeps repeating. But when you take the antiderivative, you go up one layer. So the antiderivative of sine, you go up, would be negative cosine. The antiderivative of cosine is sine. The antiderivative of negative cosine, negative sine. So when you integrate, you're going to go up. If you know that pattern, take the derivative, you go down. Okay. What about number 11 here? The antiderivative of secant x tan x. Yeah. Secant x plus c. Because if you take the derivative of secant of x plus any constant, you get secant x tan x. Anyone 4 for 4? I won't keep asking. I'm just wondering. Oh, it's pretty good. You find. But this way you'll know what you have to study tonight and really go over. Number 3, the antiderivative of 1 over x. Cameron. Nice. You remember the absolute values. I bet a lot of people didn't. So if you didn't, make a note to yourself, you know. Number 4, the antiderivative of 0. Yes. C. Yep. Just a constant. Because the derivative of any constant is 0. Number 5. Emily. E to the x plus c. Correct. 6, a lot of people make mistakes on. You sure you want to try, Manny? All right. Yes. See, when you take the derivative, you multiply by the ln of a. But when you take the antiderivative, you divide by the ln of a. Good job. All right. Number 7, the antiderivative of a constant k times f prime of x. Oh, Audrey, is your hand up? Oh. All right, Emily, that's you. You gotta alternate. K, whatever the constant is, you leave it if it's a multiplier, times f of x plus c. Just keep the constant and multiply by the antiderivative of the function. Number 8, the antiderivative of f prime of x plus or minus g prime of x. F of x plus or minus g of x plus c. Yeah, when you integrate a sum or a difference, you're allowed to integrate each of the terms separately. Okay. Number 9, the antiderivative of cosine x. Brilliant. Sine x plus c. Not so bad, right? All right, the antiderivative of secant squared x dx. All right. Tan x plus c. Good. Number 13, the antiderivative of cosecant x cotan x. Sure. Negative cosecant x plus c. Nice. The antiderivative of cosecant squared x. Many. Negative cotan x plus c. When do we get to those guys, the inverse trig functions? We just got to remember which is which. Jelly. Yeah, we're on 15. It's the inverse. Not. Cameron, what are we going to say? Yeah. Yep, the inverse of sine. Were you just about to say that, Jillian? Yeah, sorry. That was nice. All right. Ooh, the next one, there's no radical down there, and it's a plus. Which one is that? Jan, all right. I knew that wasn't real, but I was going to pretend it was. Yeah. Yep. The inverse tan of x plus c. Remember, the one with the plus is the tan. All right. This last one, there's all sorts of room for error down here. Who wants to try that one? Cameron. Okay, somebody add one little thing to that. Put those on there. And you got it. That's your quiz, just the order is going to be different. So, now what percentage would you say you know at this point? Like, know completely? 85, 25%? 60, 70? Okay, but at least you have a reality check. So what you want to do is go back to it, just like when you have some downtime every once in a while, maybe you're in a class and they're doing other stuff, it's boring. You just look at it, you go through it. Maybe you go through it like 5 times, short periods of time, but going through it, not just waiting until when you're done with your Netflix tonight at 12:30 or whatever you're doing, and your brain's tired. It's better to just keep going back and, yeah, all right. Okay, so now we're just going to go over the homework. The answers are on the flip side of this quiz, so check it out. We're going to go through anything you had questions on. Oh, good question. Let me get my questions out. Okay, why isn't 1C was the question? So let's go to that one. Okay, so you think that the answer is, now this is a little question mark, pi over 4 plus 6. So I write that down, and I want to check my answer. So I'm going to take the derivative of my answer to check. Because if I take the derivative of my answer, I should get pi cubed. Why isn't the derivative? What is this? When I take the derivative of this term, it's not pi cubed. It's a constant. So what is the derivative? 0. So this is definitely not the right answer, okay? Because the derivative is 0, not pi cubed. When you do you remember that one of the rules we just went over says when you integrate a constant, because pi, it doesn't change, and pi cubed never changes. It's not like, oh, you know, depending upon what you put in, you can't. It's always the same number, just like 7 never changes, you know. The number e is a constant and never changes. It's always 2.7. Even though it's irrational, it stays the same. So when you integrate a constant, you multiply that constant by x. Okay? And so, yeah, this is just going to be pi cubed times x. 6. Yes? 7. Okay, so we're integrating 3 over u to the 3/4 minus 4 times the cube root of u plus 1. So the first thing we have to do is rewrite this so we can use our power rule. The first term, how can I rewrite that? 3u to the negative 3/4. Right? You always leave the number. Just bring it up with a negative exponent if you have to. What about the next term? We're going to leave the negative 4. What about that cube root of u to the 1/3? U to the 1/3. Good. And then the 1 is fine. So now we're going to integrate each term. And now our variable is u instead of x. So first you add 1 to the exponent. Negative 3/4 plus 4/4, because 1 is 4/4. What would be our new exponent? Positive 1/4. Now, whatever was out here is still there, but we have to also now, you have a choice. You either divide by a 4th or multiply by 4. I think it's easier in this case to multiply by the reciprocal, right? So we're going to multiply by 4. So at the first term, it's going to be 12 u to the 1/4. Right, you add 1 to the exponent, and you multiply by the reciprocal of the new exponent. The reciprocal of 1/4 is 4 over 1. 4. Yeah. You do? Okay. Sometimes people try to like flip the old exponent. You can't do it. It's got to be the new exponent. Either you multiply by the reciprocal of the new exponent or divide by the new exponent. When it's a fraction, it's easier to multiply by the reciprocal. The next term, so first we've got the minus 4 here, but we're going to add 1 to the exponent. What's 1/3 plus 3/3? 1/3 plus 1, 1/3 plus 3/3? 4/3. And then we're going to multiply by the reciprocal. So we're going to multiply by 3/4. So, right, minus 3 u to the 4/3. And now we're up to the 1. And that, so we'll just say u plus c since that's the variable. And that's it. With the fractions, yeah, adding 1. You know, if you have fifths, add 5/5. If you have fourths, 4/4. What else you got, kids? What do you want to go over? Number 11. Yes. Okay, you know when it comes to integration, never ever products quotients, right? And unless it happens to be a formula like secant x tan x, then that's fine. But you're going to have to do some work if you have a product or a quotient. When what's down here is just a monomial, usually what you want to do is just break it up. So in other words, we're going to break it up sine cubed x over sine squared x minus 5 over sine squared x. So you break it up and you simplify each term. What's sine cubed x over sine squared x? Just sine x, and that's good because we know how to integrate that. Now, the next one, that's a pain because I don't have a, if I just leave it minus 5 over sine squared x, I don't know how to integrate that. I don't have a formula. You can change it to cosecant because you can think of that as being 5 times 1 over sine squared x. So instead of thinking of it as being 5 divided by sine squared x, we're going to think of it as 5 times the reciprocal, which is cosecant squared x. Anytime you have like anything in the denominator, instead of dividing by that, you can multiply by its reciprocal. The reciprocal of sine squared x would be cosecant squared x. Now we can actually integrate these. So the antiderivative of sine x. Good, guys. That was good. Now, let me just write the minus 5. Do you remember what the antiderivative of cosecant squared x is? Negative cotan x. So it would be minus 5 times negative cotan x. So I'm just going to make it plus 5 cotan x. Minus 5 times negative cotan x. Next question? Yep. 14. So again, we have a quotient, so we know we've got to do something. We're never, ever just going to integrate the numerator and the denominator separately. If you look at that numerator, what are you just itching to do? Dots. You just want to, because if you can simplify it, it won't be a quotient anymore, and you'll be set to go. So when you factor that, that's one of the reasons we factor. To solve equations equal to 0, but the other one is to simplify. So this is really just the antiderivative of x minus 4. And that is nice, right? What's the antiderivative of x? 1/2 x squared. And what about the minus 4? Minus 4x. Then we got plus 3. But yeah, you see a quotient or a product, unless it's one of the actual antiderivative formulas, you're going to have to do something first before you can take the antiderivative. 13? Nice. The antiderivative of cosecant x over sine of x. So I'm dividing by sine of x, but that's not one of our formulas. So you got to rewrite it. We have to do something. Yeah. See, you see how, like, I could think of this as being cosecant x times 1 over sine of x? So sine x in the denominator is the same as what in the numerator? A cosecant in the numerator. See, whenever you see anything in the denominator, I could just replace that it's reciprocal in the numerator. Because, you see, if I split it up, maybe it's easier for you to see, that's just cosecant x. See how it's just so now we're integrating cosecant x squared, and as long as you know your formulas, you're good to go. What is the antiderivative of cosecant squared? You got it mixed up with another one. That's the derivative of negative cotan x. Questions? questions out of any of them? Did you guys get 17? No. No? See? Yeah, there's the one. So it's a product. Products and quotients, bad when it comes to antiderivatives. So you cannot integrate them separately. It's not a sum or a difference. But you can actually multiply. Just like with the quotients last time, we just divide first. Well, we'll just multiply first. When you multiply, that would be x to the half, with the same base, what do you do with the exponents? Add them. Now, that exponent is a fraction. So if you want to add with fractions, what do you need? Common denominator. Okay. So 4 is how many halves? 8. So we're adding, remember we have to add the exponents. So this is the same, what do you get when you multiply x to the 8 halves times x to the 1 half? X to the 9 halves. Oh, now we can use our power rule. So if we add 1, which is 2 halves, to the exponent, what do we get? 9 halves plus 2 halves is 11 halves. And then we multiply by the reciprocal. What other ones you guys probably got messed up? Don't be afraid to ask, because I'm sure other people are confused too. You see for number 12, because when I was checking papers, a lot of people had that one blank. For 12, look at that first term. It's 3 over cosine squared x. What is that the same as? Well, 3 divided by cosine squared x is the same as 3 times secant squared x. And then you can actually integrate it. Did you get that? You want me to show you that one? No. Are there any other ones you wanted me to go over? All right, then. But then tonight you're going to be doing the rest of these. And I do want to just bring up a couple things that I remember that there were going to be problems, and I just want to tell you right now. Okay. There are certain trig identities you have to know, okay? Like secant is 1 over cosine and sine is 1 over cosecant or vice versa. But they're also the Pythagorean trig identities. And I think most people know the one with the sine squared and the cos squared. How does that one go? Sine squared x. Okay, that's the most popular of the 3. But there are actually 2 other ones that sometimes you need to know to answer these questions. So if you divide every term of the original one by sine squared x, what would you get for the first term? 1. But sine squared x over sine squared x would be 1. Plus, what about if I divide cos squared x by sine squared x? Cotan. Very good. And what about 1 over sine squared x? Cosecant squared x. That's another trig identity. And there's one other Pythagorean trig identity. And that one you get if you start with the original and you divide every term by cosine squared x. Let's see what that one would be. These you don't have to memorize if you know how to get them. What would sine squared x over cosine squared x equal? Tan squared x. Plus cosine squared over cosine squared, 1, equals 1 over cosine squared, secant squared. Okay, you might say, why do we have to know this? Because suppose I ask you to integrate this side. Oops, there's a 1 here. I say, find the antiderivative of tan squared x plus 1. You can't integrate tan squared, right? You can integrate the 1, but you'd be stuck. But what could you replace this whole side with? And do you know the antiderivative of secant squared? Yeah. So this antiderivative would equal that antiderivative, which would equal antiderivative of secant squared x, tan x. You see, so that's why you'd want to do it. If you see, like cosecant squared x, we know how to take the antiderivative of that, right? So if you see something else with a cotan squared and a 1 or something, chances are you're going to need to substitute in first, then you'll be able to integrate. So you just want to be aware of these. Okay. We've seen where you had to integrate sine squared x plus cos squared x. We had that one. So we said, oh, that's just the antiderivative of 1, which was x plus 6. I think I've hit the big things. So I'm going to give you not much time, like 8-9 minutes, to work on the rest of this, work on it for homework. Just don't forget to study small intervals. Make sure you know those formulas perfectly for tomorrow.